In this video, I'm going to discuss the smallest value after replacing with sum of prime factors problem which occurred in the LEETCODE weekly 324 contest. It states that you will be given a number n and you have to replace it with the sum of its prime factors, and then you have to go on replacing it and you have to find out the smallest number that can come as the answer. Okay, so let's say for 15 the prime factors are 3 into 5, so 5 plus 3 is 8. For 8, the prime factor is 2 into 2 into 2. So 2 to 4, 4 plus 2, 6. For 6, prime factor is 2 into 3. So 3 into 3 plus 2 is 5. For 5, only 5 is there. Okay, only 5. So now here comes the trick, that is 5 is the smallest number that is possible. Okay, 5 is the smallest number that is possible. For, so for 3, 3 is there. It goes on become 3. So 3 is the answer. Okay. For 4, 2 into 2, that is 4. Again, 2 into 2, that is 4. So I chose this condition because if you go by thinking that if it's not further, if it cannot be further breakdown, then you have to find that answer. So in this case of 4, you will see that even if it can be broken down into two parts, still the answer would be 4. Okay, so this is the exception case. This is a very important case. 4 is a very important case. So let's go into the code directly. While true, that is a just ran a while loop, and k is equals to 2. Okay, k is equals to 2. That is k would be the prime factors. So if n mod k is equals to 0, that is n is divisible by k, then nn, that is the new number. Okay, new number, that is for this case let's say 5, 6 and 8. So nn is this thing. Okay, sorry. So nn plus is equals to k, n by is equals to k, that is we are dividing it. The simple rule of prime factor, count plus plus, this is just to make the just to, this is just a variable, you can exclude it also. Okay, exclude, not important. Okay, that's not important. So else k plus plus. Now if n is equals to 1, that is it has been already reduced. Okay, because we know that in prime factor, let's say for 8, if we have prime for 15, so 3, then 5, then 5, then 1. So once it has come to 1, we simply know that it has been prime factorized. That is, if n is equals to 1, in this case you have to check that whether nn is equals to max or not. So let me say one thing, max was equals to n. Okay, previously. So if both the numbers are equal, that is in this case 4 and 4 are equal, 3 and 3 are equal, in that case what will we do? We will be breaking the statement. Okay, just simply break. And if not, then n is equals to nn, that is we are going to make n as the sum of factors, that is replacing, this is the replacing portion. Okay, this is the replacing portion, and this becomes 8, that is 5 plus 3, 8. And nn is equals to 0, that is we are going to initialize every variable from the beginning. Nn was initially 0 also, nn was initially 0, k was equals to 2. Okay, so nn equals to 0, min is equals to mat dot min n comma max. This is the trick, that is n comma min, sorry, I am really sorry, n comma min. This is the trick, that is we have to find the minimum element, but it doesn't make sense much, but this is just to make sure that we are finding the minimum element. I don't know about the exceptional cases. So k is equals to 2, count is equals to 0, max is equals to n. Simply the variables that were initialized. Okay, sorry, yeah, this one, the variables that were initialized, we are simply doing that. Count is equals to 0, this is an optional, again I am saying this is an optional, you don't need to do this. In case you need to verify the answer why the code works, you can check out why we are using count, but this is not necessary. So after that we have to return min. So this is basically the code for this program. It's a little bit not clear, but that's it. So yeah, thank you.